how did I know that this would be the key that fits this lock? And of course the answer is maths, but it's interesting maths. So I need some space, right? I'm going to sort of barrel out a few new words at you, try and keep up, but I'm going to take you under the hood now and show you where this all comes from, okay? So this is, how does it work? Okay, step one. The first step is you need to pick two prime numbers. Two prime numbers, any prime numbers you like, okay? Now, as will become clear in a second, when this is done in real life, right, these prime numbers that get chosen are enormous, and they have to be enormous. Hundreds and hundreds of digits long, okay? If it's not, the whole thing doesn't work, and you'll see why shortly, okay? I didn't choose enormous numbers because then the maths would be impossible to follow. So I picked small numbers. I picked 2 and 7. So I'm going to call that P equals 2, Q equals 7. Okay? All right. So step 1, pick two prime numbers. Okay? Step 2, come up with a number that's the product of those. I'm going to call that N. Right? The product of P and Q, which in this case is 14. Okay, so I've multiplied my two primes together, whatever they were, and this is the number I end up with. Now you can recognize this number, right? This number becomes the modulus in my encryption key and my decryption key. Okay, so this number eventually gets publicized. Okay, but these numbers do not. It's important. So I multiplied them. This number is critically important. Step 3. I then need to work out this funny little thing called the phi function, okay? Now, you're like, wait, phi? No, it has nothing to do with the golden ratio. There just aren't enough Greek letters to go around, so they just get reused, okay? Now, what is the phi function? It's this really cool idea that I picked this number, 14, 2, and 7, because it's small enough to list out all of the numbers, okay? So let's just quickly, on the side here, list all the numbers 1 to 14, okay? Now, in this list, some of these numbers, right, have common factors with 14, and some do not, okay? Common factors. I'm not including 1 because 1's a factor of everything, okay? So have a look at this list with me. The factors of 14 are 2 and 7, see? And because, this is important, because they're prime, they're the only factors, right? Does that make sense? So what I'm going to do is, as I go through this list, I'm going to cross out all of the numbers that share a common factor with 14. Okay, so have a look. Remember, I'm not worrying about 1, so because he's a factor of everyone. So I'm going to cross out 2, because it has a common factor with 14, namely 2. Okay. In fact, you can see now, I'm going to have to cross out all of the even numbers. Can you see that? Because every even number on this list has a common factor with 14. Does that make sense? Yeah. So I'm going to cross out 2, 4, 6, 8, 10, 12, and 14 itself. Okay. Now, are there any numbers left on this list that have common factors with 14? 7. And the answer is 7. So I cross out 7. All right. How many numbers are left? The answer is 1, 2, 3, 4, 5, 6. Okay. So these numbers are important. These numbers, they are called co-prime with 14 because they share no common factors with 14. Okay? 1, 3, 5, 9, 11, and 13. I know you think you're talking softly. You are not talking as softly as you think you are. Okay. Keep this word co-prime in your head because I'm going to use it again shortly. Okay. Now, here's the first thing you could do. You could just count these up, okay, and you would come up with this number. It's 6, right? That's the answer to this number. But you're like, hold on a second. I told you at the beginning that really these numbers should be enormous, right? If these numbers are enormous, then this number is going to be enormous. And do you really want to write down all of these and count them all out? So, wait for this. There is an easy way to compute this number, 6, without counting it out. Watch this. It's equal to this. Okay? So you took the two original numbers that you multiplied together to get n, right? You subtract 1 from each one, and then you multiply it. So you subtract 1, you get 1. You subtract 1, you get 6. 1 times 6. What? Now, you're like, oh, 1 times 6, that's not hard. You just go ahead and try this. Try this with a bit of a bigger number. Try it with, like, say, 3 and 11. Because that's like 33. You can still do that, but you're starting to get to the point where you're like, I don't want to do all these, right? I can tell you right now, 3 and 11, 33, there will be 20 co-prime numbers with 33 under 33. Exactly. 2 times 10. Like, what? How does that work? Well, if you game and you think that this piece of homework is easy, you can have a tackle at why this is the answer to this particular problem, okay? But for now, the point is that is the answer, okay? I need this number. 5n is 6, okay? All right. That was step 3, okay? Step 4. Now I'm up to the point where I need to pick this number, okay? This number, I'm gonna call it E for encryption, okay? So I want to choose a number for E, and it has to fit certain properties, right? You can't just pick it randomly. And I'll show you the properties. The properties that it's going to obey are based on what we've just worked out, okay? So E has to obey these 2 properties, okay? Number 1, it's got to be between 1 and this number, 5n, okay? That's the first property. It's got to be between there, right? So you can see, I don't have that many to choose from already, okay? But secondly, and even more important, it must be co-prime with n and 5n. Okay, pause. Let's just think about what that means. I'm trying to pick a number. Okay, the first condition is it has this limited range. It's got to be between 1 and 6. So automatically I only have these options. 2, 3, 4, 5. Okay. So out of those numbers, I want to select one. I want to choose one that is co-prime with 14 and with 6. I want to pick one of these numbers that doesn't have a common factor with 14 or 6. Now have a look at those, right? Automatically, I can already, just like I did before, I can eliminate all the even numbers, right? So look, 2 and 4, they're out. They're not going to be co-prime, right? Then you look again and you're like, wait, 3? I can't use 3. Why not? Because it has a common factor with 6, namely itself, right? So it's a done. So all you get left with is 5, okay? So E is 5, which is where I got this number from. Okay, it's not random. It obeys these conditions. Okay. All right, so now I have, at this stage in my algorithm, is it really that hard? At this stage, I now know my encryption key, or should I say, the lock. This pair of numbers is the lock that I'm going to hand out to everyone. Okay, so cool. Well, now I need to work out the key. All right, so step 6. What I need to do now is I need to choose this number, find this number, which because I call this E for encryption, I'm going to call this D for decryption. Okay, so D, again, it follows certain rules, okay? Namely, choose D such that it follows one condition, okay? Yeah?
Did you skip step number 5?
Sorry? Oh, right. Yeah, the secret step. Okay, step 5, right? No wonder it's so hard to crack. Step 5, I'm going to choose this number D such that D times E mod this number, which we just worked out as 6, I want it to be equal to 1. Okay. Now, what does this mean? Okay. Let's translate this, because this is in a general case, to our specific case. Okay. We know what E is, the encryption number. It's 5. So I want some number such that 5 times D mod 6 will give me 1. Okay. 5 times whatever number I choose, when I do mod 6 on it, I should get 1. Okay, so 5D, what are the numbers that fit this pattern? Well, they're the multiples of 5, aren't they? 5, 10, 15, 20, etc. Okay, so what I'm going to do is I would write them all out and then do mod 6 on them. Okay, so let's just quickly do this, right? So here are the numbers I now get to choose from, right? Okay, And then I'm going to say, well, what's mod 6 of each of these numbers? Okay? So think about this with me. What's 5 mod 6? Not hard. 5. What's 10 mod 6? 4. 15 mod 6? 3, because you can take away 2. Right? 20 mod 6? You can take away 18. So this, can you see a pattern? What would you expect? Then what? I haven't written it down, but you can think about it, right? It has to be 0. Why does it have to be 0? It's not a coincidence. It has to be 0, not just the pattern. Why?
Because it goes into it.
This is the first multiple of 5. And then the second multiple. And it's the sixth multiple. Every sixth multiple is a multiple of 6. Which is why when you do mod 6, it doesn't have a remainder. Is it clicking? Is it making sense? Okay. Now, you can see what's going to happen. This pattern is going to repeat, right? So I can pick any of these numbers where I get a 1. Okay, where I get a 1. I can choose a whole different bunch. Now, for reasons that it's a little harder to explain, I don't want to pick this particular one. It's going to make things too easy, okay? So I'm going to pick a later one. The number I've chosen is 11. Okay, the number I've chosen is 11. You can pick any of them that end up with a 1 and it'll work out. Okay, so I choose D equals 11 because if you do 5 times 11, right, and then you do mod 6, that's 55, right? So 55 mod 6, you take away 54, and that leaves you with 1. Okay, so now I have the key. The key is 11. 14.